Hey there, welcome back to my channel, to the second video of tree series. So in the previous video we completed the in-order traversal, and in this video we will complete the pre-order traversal. Just the difference between the in-order and the pre-order is, in order the parent was in between the left and right child, and here, whereas in pre-order traversal we first go for the parent and then left and right child. Okay, so let's take the same example as we have taken in the previous example, that is the same one which we discussed in the previous video. I'll just write it very quickly. Yeah, the same example, and the here output should what the output will look like is like this. So let me write this output here on top. So 1, and then go to left, 2, again go to left. So come here again, it will be this and like this and this, not 8, it will be 6 and then 7 and then 9, 10. So this is what the pre-order traversal of this tree looks like. Okay, so let's directly jump into how the traversal is happening. Okay, so let's assume the initial the root node that we would be at is at this node 1. So since this is we have to go from parent, left and right. So this is the parent, so straight away we'll print the 1. So that is where we see here as 1. So go to its left child. Yeah, so is there a left child? Yes, we go to this 2. Again, this would become now the parent node, that is root node. So next output would be the 2. Okay, so that is how we see 2 here. Again, is there a left child? Yes, we go to, oh my god, just a second. Okay, so this, now we go to the left part, and this would become the parent node now. So this we print the 4. Again, check for left and right part, there is no more, so we go back to the parent node 2. Again, check for the right node. Now the 5 will become the root node, so that is why we see the next output as a 5. Again, check for the left node. We go for the left node, that is 8, and this would become the parent node now, and I'm printing that. So again, check for its children, there's no children left. We go back to its parent, and this is there is no right child, so we are done with this node as well. We go back to 2, and the traversal for this 2 is also done, and then go back to 1. So this one is also done. So we'll go for the now right child of the root node 1. So the next thing which will be going is the 3. So now this will become the parent node. Okay, so the parent node, so we have to print this one. So that is why you see here 3 is being printed. So once we are done with this, we go to the left child of the root node 3. So we go to this node 6. So now this would become parent, and we print this here 6, and check for the left child, there is no left child, and check for the right child, there is no right child. Go back to its parent, again check for its right children. Yes, there is right children, so that is 7. We come here, and this would become the parent now, and we see the output here as 7. And now check for its left child. Yes, there is, so we go back to 9 and print the same here, and check for left and right, there is no child left. Go back to its parent and check for its right children. Yes, there is 1. We go to 10 and we print this. I check for its left child and right child, there is nothing left. So that is how the output we are seeing here will be derived, okay, from this pre-order traversal. Okay, fine. So this was the high level traversal, how it happens in this tree if you follow the pre-order method. Okay, fine. So now coming down to the pseudocode, just same as the previous one, I'll just write quickly, like, let me name this as pre-order traversal, and here I'll pass as a root, and same base condition should be there for recursion function calls. If root is null, we just come out of this function, and here the first thing is we will print the root value here first, that is parent value. So that's the difference between the in order and pre-order, and then later this will make recursive function call to the left children of the current node we are at. So pre-order traversal, So route to left, and the same pre-order traversal, route to right. Okay, so this is the pseudocode for this pre-order traversal. Okay, fine. So now let me explain the function calls by using stack, and so that it will be clear for us. Okay, so I will take so this is what function calls will be happening. So currently we are at node 1, so directly I'll print this one. So this is print 1. So is there a left child for this? Yes, there is left child. So we'll go to the left child, that is 2. Okay, and then print this one. So this is parent first to be printed, and then same thing. Is there a left child for this? Yes, I mean we print it again, left child is there. Yes, we go to 4 again, we print 4. So this is 2. Okay, okay, fine. We go back to the left child again. Is there for this there is no left child, so I'll just keep n for the null. So here the check will come now, if root is equals to null. Yes, return, yes, that is true. So what we do, we return to this previous function call. So it will become like this. The stack would be like this now: 1, 2 and 4. Okay, so it came back to the 4 again. It will recursively call the right child on this root node 4. Since okay, we again add something like this n, and we'll see again, check if root is equals to null. Yes, this is true again, so it will return back to its function call. Okay, so if I write this now, so it will become like this, that is 1, 2, 4. Okay, so we'll be at this, and since the traversal for this is also done, the stack would look like this, that is 1, 2, that's it. Okay, so 2 here, 2 was here, so we are done with the left part. Again we'll check for the right child. Yes, there is a right child, so what we do is we push the right child of it. So here, so we will print here print 5, and print 5 again, we go for the left child of the root node 5. Okay, so that is there is a left child, that is 8. Again print that, print 8. Okay, so again we go for the left child of 8, there is none, and right child of 8, there is none. Again it will return and come back to the 8. So next the stack would look like this. So since there is nothing more left to explore on 8, we would be taking off from that stack. Okay, and also we are at the root node 5, and there is no the right child of function, I mean root node 5. So this will also be taken off the stack. So now we would be at this. So now we are at this second root node 2. So this is also, we have explored the left and right part, so this will also be taken off the call stack. So like this. Okay, I'll write new stack here. So finally this is where we are at now. So 1, so the left child of the root node 1 was explored. So now the right child. Okay, so right child is 3. Yes, there is a right child. So what we do is we push 3 and parallelly print that number. So then print 3 again, check if that is null. No, so we printed that, and check for the left node of the root node 3. So there is a there is left child which is 3, so we will print that as well, that is print 6. So since there is no left and right child for the 6, we go back to we check the condition root equal to null becomes true. Again we'll add into that stack, it will come back to the 6, and no more child left to explore 6, we will remove it of the stack. So this is how it will look like. So next, this is, it will be 1, 3 Yeah, 6 will be removed. Okay, so 3, we were at 3. Yes, now we'll check for the right child of 3. Is there a right child? Yes. What is it? That is 7. So here we print that 7, and again now we will check for, is there a left child of for root node 7? There is, so that is 9. So we print that is print 9. Okay, fine. And we check again for left and right child of 9. There is none left, and we would be taking what it off the call stack. So now what the stack will be looking like this. So it will be like this, and we are done with the left child of the root node 7. We'll see if there is again a right child for the root node 7. Yes, there is. So that is 10, and we will print that, print 10, and check for again left child and right child of 10. There is none left. Again it will return, and the thing doing with the node 10 as a root will be completed. So we'll take it off the call stack. Okay, we'll take it off the call stack, and it will become like this. And also root 7 also is explored the left and right child, and there's nothing to explore more on root node 7 as well. So this will be also done. Similarly for 3 as well, we have explored the both the left child and right child. That is also done, and 1 is also done. So finally the stack will be empty. So once the stack is empty, it means that the traversal is completed. Okay, finally this is the output that we'll be seeing. Okay, see the output is, let me write in the because direction 10 was printed, and then 9 was printed, then 7 was printed, then 8 was printed, 5, okay, then 6, 3 was printed, then 4, 2, 1. So this is the output. Let's compare it now, how this is it matching to the what we were discussing before. Okay, so let me take it to the top. Okay, let's check. Let me take it to the top and check now. 1, 2, 4. There is a difference. Okay, did I write it wrong? I think I wrote the order as wrong. Where is it? Okay, I think I misshuffled the options here. Just, but usually this is how it will be done. So here 5 and 8 and 3, 6. Okay, I think I misplaced the order. So this is what the output will look like at the end. Okay, so that is the explanation. Now we will jump on to the coding part and see the output is matching it or not. Okay, so we'll write the code for the pre-order traversal, which we discussed now. So I will include the headers. I mean, I was stream, I've been needing, and also I've been needing vector. Okay, and then space. Fine. So first I'll define the data type, that is int val, and also struct node left and right pointers. Okay, and we will write the preorder traversal function. So here we will pass root node and also the preorder array to store the traversal of our tree, and then the base condition, if root equals to none, we will just return here. If then first thing is we have to push the parent value into the pre-order array, that is I'll push root to val, and here we traverse to the left children, okay, and then to the right children. Okay, so this is pretty much the pre-order traversal function, and then we will write one function to create a node. Okay, new node, let's name this as a new node, and input will be value parameter, and then I'll create one temporary node. Okay, of type struct node star, and then we'll allot memory that is needed for this node. So okay, and then I will assign the value to this node, which we will be receiving as input parameter, and then left and right child I'll make it as a null. Okay, so this is it, and then we will create main function and execute and recreate the same tree structure, that is, let's name this as root new node as 1, and then quickly recreate that structure, new node of 2, then root to left is 4, and then root to left to right is again new node of 5, and root to left right to, okay, I missed here, left will be new node of 8. Okay, so and then right child's now, so root to right is 3, and root to right to left is 6, root to right is 7, and then 2 more nodes, root to right to right is 10, and then root to right to left equals to 9, I guess. Yeah, so that is what we missed, and we'll create one array, and then I'll call that function pre-order traversal and pass the root node and pre-order, and then finally we will print that pre-order traversal, pre-order traversal, and write one for loop to traverse through that array. Okay, and then I will print that thing, and I think I missed here semicolon, and finally return 0, and let's check the output of this code. Okay, something is missing. Fine, I think I should run code. Okay, I missed something at this. Okay, fine. Oh, I missed here return type. Return temp. Okay, I think we should be good now. Let's check. Yeah. So if you see, pre-order traversal is 1, 2, 4, 5, 8, 3, 6, 7, 9, 10. That is what exactly we needed. Yeah. So thank you. This is it for this video. Please stay tuned for the upcoming videos on this channel. Thank you so much.